You are welcome to the GMAT 41 Basic Mathematics 2 class. In our last class, I taught you how to carry out addition and subtraction of numbers in standard form. I explained to you one important thing you're expected to know as a secret in order to be able to add or subtract numbers in their standard forms. I mentioned that the powers of 10 of these numbers you want to add or subtract must be the same, must be equal. So if a question is given to you and the powers of 10 are not the same, of course you are expected to move points in order to make the powers of 10 to be the same. Then you are free to add and or subtract. In our class today, I'll be teaching you another arithmetic operation on standard forms, how to multiply and divide numbers in their standard forms. So how do you do that? Today, I'll be introducing just two laws of indices to you, which is going to guide us on how to carry out multiplication and division of numbers in standard form. There are more than two laws of indices, but we just need two of the laws as secrets to help us be able to multiply or divide numbers in standard form. So let us quickly look at these two secrets, okay? Number one, multiplication law of indices. If you're given two or more numbers to multiply the numbers in standard form, you need this law of indices called multiplication law to guide you in order to do this multiplication successfully. And what does this multiplication law of indices say? It tells us that if you are multiplying the same numbers, these numbers, refer to them as bases, you are expected to pick one of the numbers and then add their powers. Once again, you are multiplying two or more numbers that are the same. Simply pick one of the numbers and add their powers. That is what multiplication law of indices tells us. I have a quick example here to guide us. If I give you something like 10 raised to the power 5 times 10 raised to the power minus 3. Now if you notice here, the numbers you're multiplying is 10. Okay? 10 raised to the power 5 times 10 raised to the power minus 3. So we are multiplying these terms, okay? Now, because these numbers are the same, we call it the base. If I give you something like 2 to the power of 5 or 5 to the power of 9, okay, 2 to the power of 5, that 2 is the base. The 5 is the power. If you have something like, okay, 6 raised to the power 3, that 6 is the base, the 3 is the power. So here that I'm multiplying 10 to the power 5 times 10 to the power minus 3, the bases are the same. 10, 10. So pick one of the 10 and then add their powers. So this 5 and minus 3, I'm going to add both of them together. And you can see that 5 plus, that is 5 plus, the law said you should add powers. Then you are adding minus 3 to it. You can see the minus 3 in brackets. So this is going to give us 10 raised to the power 5. Now watch. Plus times minus will give us minus. So this will actually become 10 raised to the power 5 minus 3. And 5 minus 3 is 2. So this term will give us 10 raised to the power 2. Which means 10 raised to the power 5 times 10 raised to the power minus 3. Following multiplication law of indices, you get 10 raised to the power 2 for this. Now look at this one. 10 raised to the power 4 times 10 raised to the power 2. Again, you are multiplying these terms. The bases are the same, the numbers are the same. So pick one of the 10 and then add the powers 4 and 2. So this is 10 raised to the power 4 plus 2, which of course will give us 10 raised to the power 6. So that is all about multiplication law of indices. I use 10 as examples here, alright? But if maybe I give you something like 3 raised to the power 4 times 3 raised to the power, let's say 7. You are multiplying the same basis, 3 to the power 4 times 3 to the power 7. So you pick one of the 3, then raise to the power 4 plus 7, which will give you 3 raised to the power of 11. I've given you a good idea about multiplication law of indices. In classes to come, when we discuss indices, you shouldn't have problems with that again about multiplication law, because I've just explained that. Let's move on to secret number 2, division law of indices. It's another secret you need when you are multiplying or dividing numbers in their standard form. We apply this for division case, okay? And now this division law of indices tells us this. If you are multiplying the same numbers, that's the same basis, pick one of the base, pick one of the number, and then minus, subtract, take away the power of the denominator from the power of the numerator. Once again, you are giving two numbers to divide. These numbers, they are the same. Now they have their powers. Because these numbers are the same and you are dividing them, division law of indices said you should pick one of these numbers. Then you do power of numerator minus power of denominator. A quick example here to guide us: 10 raised to the power 5 divided by 10 raised to the power 2. Now you are dividing this 10 to the power 5 by 10 to the power 2. The bases are the same, okay? The same number, 10, 10. So I pick one of them. You can see the 10 here. So it's going to be power of the numerator, which is 5, minus the power of the denominator, which is 2. You know, this 10 raised to the power 2 is the denominator. If I give you A divided by B, B is the denominator, A is the numerator. Okay, let's go. So you write this 10, pick the power of the numerator, then minus the power of the denominator. You can see that. 10 to the power 5 minus 2. And if you work the power, 5 minus 2 will give you 3. So this 10 to the power 5 divided by 10 to the power 2 is actually equal to 10 raised to the power 3. Another quick example here: 10 raised to the power minus 9 divided by 10 raised to the power minus 7. Now this is also the same as divided, okay? Now it's going to be equal to, you are dividing this 10, 10. The numbers are the same base. So you pick one of the 10, consider, write power of the numerator, which is minus 9. Remember that division law said you should subtract power of denominator from that of the numerator. So power of the numerator, which is minus 9, then minus, can I see this minus I wrote with black marker? Yes, that's what the division law said. You now subtract, you minus the power of the denominator, in this case minus 7. You subtract it from minus 9. That's what we have here, minus 9 minus 7. Now, minus times minus changes to plus. So this will give us 10 raised to the power minus 9 plus 7. If you work this minus 9 plus 7, you get minus 2. Minus 9, you are owing 9. You are owing 9. Plus 7, you have 7. If you give that person the 7 you have, because you are owing 9, you will still be left with 2 to pay. And because you are now owing 2 here, we use what? Minus 3. Okay, so minus 9 plus 7 will give us minus 2. Which simply means that 10 raised to the power minus 9 divided by 10 raised to the power minus 7 will give us 10 raised to the power minus 2. Again, I've explained division law of indices. When we are going to treat indices, I think multiplication and division law should no longer be any problem for you. Now, we have this question to solve. Simplify 4.1 times 10 to the power of 4 times 2 times 10 raised to the power 3. Okay, now the question given to us is this. Okay, now in solving this will be equal to, now you notice that this is 4.1 times 10 to the power of 4. This one is 2 times 10 to the power 3. Let me tell you something quickly. If I give you 5 times 3 times 2, it's the same as 2 times 3 times 5. It's the same as 2 times 5 times 3. It's the same as 3 times 2 times 5. See, the way you arrange multiplication under basic arithmetic does not matter. That is why 2 times 4 will give you 8. 4 times 2 will still give you what? 8. So this number that I have here, I want to do something. You see this 4.1 and this 2, I want to bring them together close. Then this 10 to the power 4, 10 to the power 3, I want to also write both of them close. So that I'll have 4.1 times 2. Then times 10 raised to the power 4 times 10 raised to the power 3. Good. We are now going to multiply this. If you multiply this 4.1 by 2, you are going to get 8.2. Come over here times, you are multiplying the same base here, 10, 10. Multiplication law of indices said you should pick one of the bases, one of the numbers that are the same. So I've picked one of the 10, then add their powers, 4 plus 3. In conclusion, therefore, 4.1 times 10 to the power 4 multiplied by 2 times 10 to the power 3, the answer is going to give us 8.2 times 10 to the power of 7. Answer. How did I get times 10 to the power 7? 4 plus 3, this power of 10, 4 plus 3 here will give us 7. I hope this is clear, right? If you do have a question and this, you know you can always send your question across and you will get immediate response. Let us move on to question number 2. And now let us solve our second question. It has A and B parts. Solve 1.6 times 10 to the power of minus 2 times 3.1 times 10 to the power 8. And the question requires that we write our answer in I, standard form, II, ordinary form. Let us see how we solve this problem. This is question 2A. Now in the I part, we should get the answer in standard form. You know, when you are dealing with numbers in standard form, usually the first answer you get will be in standard form. So we go straight on to solve that problem. We have 1.6 times 10 to the power of minus 2, and we are multiplying it by 3.1 times 10 to the power of 8. You know, sometimes this question can be given to you and we just put them in brackets like this, not showing the multiplication. Are you following? It's still the same as multiplying. Okay, now, like we did to the first question, all we need to do is to pick these numbers, 1.6 and 3.1, those ones that are not 10. Are you following, right? Pick them and multiply them. Coming to this part of 10, just pick one of the 10 and add their powers. That is what multiplication law of indices said. Okay, so we have 1.6 times 3.1, and then we are multiplying this by 10 to the power of minus 2 times 10 to the power of 8. Now here we are going to pick one of them and add their powers. This will be equal to 1.6 times 3.1 will give us 4.96. And then we multiply it by, pick one of the 10s here, like I said, this is 10, this is 10, you are multiplying the same numbers. Pick one of them and add their powers, minus 2 plus 8. This 4.96 I obtained from here, multiplication of decimal numbers. Please take note. To learn multiplication of decimal numbers, or even addition, subtraction, or division of decimal numbers, you can subscribe to our Telegram channel on Basic Mathematics Class 1. There you have video lessons to teach you everything you need to know about basic arithmetics. The 4 of them: addition, subtraction, multiplication, and division, whether it is that of whole numbers or that of decimal numbers. But anyway, let me just do something for you. Let me quickly show you how I got the 4.96 in case you have challenge. But I've told you what to do, okay? 1.6, we are multiplying it by 3.1. Good. Now we are going to carry out this multiplication as if there is no decimal point. We go 1 times 6 will give us 6. 1 times 1 will give us 1. Then 3 times 6 will give us 18. Write 8, move 1 to this. Then 3 times 1 will give us 3. Add the 1 that you moved over to this tens place value, and then you will get 3 plus 1, which is 4. Add up this. Here will be 6 plus nothing. Here you bring down the 6. This is 1 plus 8. You have your 9 here. Okay? And then here is nothing plus 4. Okay? Just bring down your 4. Having solved this, it's important for you to know that the decimal point, which we did not show here, for this answer is just after this last digit 6. Is that okay? Then from here we'll now move the point. We'll move the point to the left hand side. But how many times will we move the point to get our final answer? It depends on the number of decimal digits you have here. And how many decimal digits do I have here? 2 decimal digits. We have 6 and 1. So I'm going to move the point 2 times to the left. 1 and 2. So you can now see that the point is between 4 and 9. 4.96. That is how I got this answer of 1.6 times 3.1. You can learn more about that anyway. Our basic mathematics plus 1. Okay, so concluding, from what we saw here, we can say that our answer, therefore 1.6 times 10 to the power of minus 2 times 3.1 times 10 to the power 8 is equal to 4.96 times 10 to the power 6. Minus 2 plus 8 is equal to 6. You are owing someone 2, that is minus 2. Plus 8 means you have 8. If you pay the person the 2 you are owing from the 8 that you have, you will still have 6 left. And because you have 6, it belongs to you, it is plus, it is positive. Are you following? So this becomes 4.96 times 10 to the power of 6. Answer. This is in standard form. Alright, now let us move on to II part of question 2a. We are to get the answer in ordinary form. To get answer in ordinary form is a simple thing to do. We get it from the standard form answer. Is that okay? So let's see how we get that. II. I'm going to write this answer in standard form, then from there I will change it to ordinary form. 4.96 times 10 to the power of 6 will be equal to 4.96. Now, look at this times 10 raised to the power 6 simply tells us that we have 6 zeros after this 4.96. Is that okay? We have how many zeros? 6 zeros. So this 4.96 is simply the same as 4.96. 1, 2, 3, 4, 5, 6 zeros. Is that okay? So what are we not going to do? Because this is raised to the power 6 and you have the decimal point here. You will move the decimal point 6 times to the right. Please take note, the zeros we attached after this 4.96. The zeros came after this 4.96. The reason is because this power is positive. Take note. So the zeros will be attached after the non-zero digit itself. From here, I'm going to move my point 6 times to the right. So we go 1, 2, 3, 4, 5, and 6. The point comes here, which means that 4.96 times 10 raised to the power 6, written in ordinary form, is 4, 9, 6. How many zeros? 1, 2, 3, 4 zeros. 0, 0, 0, 0. Then I have 0.00. This 0.00 does not mean anything anymore because the point came before them and there is no digit which is not 0 after this one. That is to say, there is no non-zero digit. So these zeros does not mean anything. You cancel them off. In conclusion, therefore, the number given to us, 1.6 times 10 to the power minus 2 times 3.1 times 10 to the power 8 is equal to 496. 1, 2, 3, 4 zeros, okay? And this, of course, you know, is 4,960,000 in ordinary form. Answer. Okay. Let us move on to the B part of the question, 2B. In the 2B, we have 8.19 times 10 to the power 7 divided by 9.1 times 10 to the power 2. We are to express our answer in ordinary form. Evaluate this, get your answer in ordinary form. Now, this question given to us is in standard form already. The first answer you're going to get will be in standard form. Then for me to change it to the ordinary form. Okay, so the question we have 8.19 times 10 to the power of 7, okay, divided by 9.1 times 10 to the power 2. This will be equal to 8.19 times 10 to the power 7 all over 9.1 times 10 to the power 2. If you look at this, I'm dividing this number by this. We need to apply division law of indices. And of course, to do that, I'm going to rewrite this as 8.19 divided by 9.1, then times 10 raised to the power 7 divided by 10 raised to the power 2. But there is something I want you to take note of here. Okay? If I am dividing this, I'm going to divide 8.19 by 9.1. The denominator is a decimal number. So it's always advisable that we change it from decimal number to whole number. Once again, in the GMAT 41's Basic Mathematics Class 1, I've already treated how to carry out division of decimal numbers. You can learn that by applying for this class, GMAT 41 Basic Mathematics Class 1. Okay, so I am going to change this to whole numbers. And how would I do that? Let me move this point 1 and 2. If I move it 2 times, I'm going to subtract 2 from the power of 10. So it's going to be 7 minus 2. I've already explained point movement, under addition and subtractions of numbers in standard form. I've also even done that when I introduced this topic. Then here, I'm going to move the point once like this, And because I moved once today, right, I will minus 1 from the power. Having done this, this becomes 819 times 10 to the power 5. 7 minus 2 will give you 5. All over, this becomes 91 times 10 to the power 1. That 10 to the power 1 is still the same as 10. A number raised to the power 1 is that number. So this 10 raised to the power 1 is the same as 10. Take notes. This will be equal to 819 divided by 91. Now, I'm dividing this number. If you look at the numerator, you have 10 raised to the power 5. The denominator, 10 raised to the power 1. Division law of indices tells us if you are dividing the same numbers, pick one of the number and minus the power of denominator from that of the numerator. So this becomes times, I'll pick one of the 10. It's going to be power of numerator 5 minus power of denominator 1. This is going to be equal to 819 all over 91, then times 10 to the power 4. Let's do this division and see what we are going to get. This is 91. 819 divided by 91. If you're good at your multiplication, you can handle this straight on. You'll notice that 819 divided by 91 would give you a whole number, which is 9. So I'm going to write that straight on. 819 divided by 91 will give us 9. So times 10 to the power 4. 819 divided by this. In fact, let me show the division there. 819 divided by 91 will give us 9. And because there is no remainder, you divide 91 by itself. So 91 divided by 91, you get 1. I've got my answer in standard form. Let me indicate. But the question said we should get our answer in ordinary form. So let us change this to ordinary form and see. This is going to be equal to 9. Now look at this. Times 10 raised to the power 4. This 9 standing alone is the same as 9.0. A number standing alone is the same as 0.0. I've explained all of this in the introductory class of this topic, standard form. We have times 10 raised to the power 4. This 10 raised to the power 4 simply tells us that we have 4 zeros after this 9.0. This could have been 9 point any other digit. That is why I had to put the 0.0 for you so that you be guided. It could have been maybe 9.135, 9.8. 9.059, whatever decimal parts. So you need to know where to move your point from. Since we have times 10 raised to the power 4, I am going to attach 4 zeros. 3 and 4. Please take note that this 0 is not part of the 4 zeros from this 10 raised to the power 4. That is why I wrote it in black shade of marker, black colored marker. This 0.0 is simply to tell you that any number standing alone is the same as the number 0.0. Is that okay? From here, I'm going to move my point 4 times to the right. Is that okay? I'll move my point 4 times to the right. So we go 1, 2, 3, 4. And this is going to be equal to 9. 1, 2, 3, 4 zeros. 1, 2, 3, 4. Then I now have 0.0. Since you have 0.0 here, after this point, this is 0. This 0 does not mean anything, just like what I explained in this part here, okay? So you just cancel it off. We can now conclude, therefore, 819, that is 8.19 times 10 raised to the power 7 divided by 9.1 times 10 raised to the power 2. The answer is going to be 90000. That is 90,000. Answer. And this is in ordinary form. And this is how we solve these problems, okay, that we have here on the board. You can go through that, rewatch the video. If you have a question, remember you can always send your question across and you will get a response. Next, we are going to look at question number 3. We have this question here on the board to evaluate 57.4 times 10 to the power of minus 15 all over 2 times 10 to the power of minus 6. It is required that we write our answers in A, ordinary form, B, standard form. Let us solve this and see what we get. The question given to us is 57.4 times 10 to the power of minus 15 divided by 2 times 10 to the power of minus 6. Now this is going to be equal to, of course we will rewrite this part out separately, okay, this 57.4 divided by 2. Then we'll come to this part of 10 raised to the power minus 15, 10 raised to the power minus 6, and pick one of them, apply division law of indices. So we have 57.4 all over 2. Now we're multiplying it by, pick one of these 10, pick one of the 10, then power of numerator, which is minus 15, and then minus power of the denominator. You know, this minus is the follow come minus from what division law of indices said we should do. Then coming to the denominator, you notice that the power is still carrying minus. So it's going to be open bracket minus 6. So you have minus minus there. Working this out, we are going to get this to be equal to, we now have to divide this part. Alright, okay, let me write it down here and then before I do the division, 57.4 all over 2, then times 10 to the power of, please take note, this is minus 15 minus minus 6, which is going to give us minus 15 plus 6. I could have gotten my answer directly as minus 9, because minus 15 plus 6 is going to be equal to minus 9. But I just had to show you that this minus times minus changes to plus. Coming over here, let's do the division and see. If 2 divides this 5, alright, let me say this before I proceed, before I go ahead with the division. Look at the denominator. The denominator, is it a decimal number or a whole number? You are correct. It's a whole number, not a decimal number. So in this case, you can do your division directly. No need of talking about, okay, converting them to whole numbers because the numerator is a decimal number. You now say, okay, numerator is a decimal number, so I have to convert to whole number. You don't need that for a problem like this. I've said this in our basic mathematics class 1 under division, that if the denominator is a whole number, there is no need of talking about that conversion, even if the numerator is decimal number. Is that okay? If the denominator is a whole number, you can divide directly. So let's see that here. 5 divided by 2 will give us 2 times remainder 1. Attach the 1 to this 7, you get 17. 17 divided by this 2 will be 8 times remainder 1. Attach the 1 to this 4. As you are moving to that part of 4, remember to put your decimal point so that you don't forget. Is that okay? Now we have 14 divided by 2. 14 divided by 2 will give us 7. So you have a 7 here. Clearly, if you look at this, the last division gave us a whole number which is 7. No last remainder. There is no last remainder. Therefore, this denominator 2 will divide itself to give us 1. So this is actually 28.7 over 1. Alright, so we have that 57.4 times 10 raised to the power minus 15 all over 2 times 10 to the power of minus 6. Our answer is going to be equal to 28.7 over 1, which is 28.7. Then coming to the part of 10 raised to the given power here. This is minus 15 plus 6. And minus 15 plus 6 will give us minus 9 times 10 raised to the power of minus 9. You see, eventually I've gotten my answer in standard form. Alright, one thing I want to tell you is if the question given to you is in standard form, you are asked to get your answer in ordinary form. It is advisable you get in standard form first, then change it to ordinary form. Always get your answer in standard form if the problem given to you is already in standard form. Then if you get it in standard form, you can easily change from there towards ordinary form. Okay, so let's move on to the A part now. We're asked to write our answer in ordinary form. To get our answer in ordinary form, what do? Now we move on to the answer given to us, what we got here in standard form. Okay, we'll go to our answer here, then we'll start working from there. Don't go and start from beginning again. Are you following, right? What we have there is 28.7. 28.7 times 10 to the power of minus 9. This is what we have here. So what do we do there? Now, I want you to take note of something. The power here is minus 9. I repeat that again. The power there is what? Minus 9. Because it is minus, not positive. Are you following, right? It is minus 9. It simply means that 9 zeros will appear before this 28.7. 9 zeros will appear before this 28.7. I'm saying this because you remember in question number 2, when we were writing it in ordinary form, the zeros appeared after the answer we got because the power of 10 there was positive. Positive. In the case where the power is negative, you write the zeros first before the number. And so that's what I'm going to do here. This becomes equal to, I hope this space will be enough for me. Let's squeeze it and see. We go. 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then this is 28.7. Let me write that 28.7. Okay. I've written the first step of the ordinary form of this number. But this is not the correct way you leave it. Because you can see the 0, 9 zeros, then 28.7. This point should not be here. Are you following, right? If you have all these zeros before 28 and then points, then these zeros are meaningless for this. So take note, you don't leave that point there. You have to move the point. Once you have done this arrangement, now you have to move the point 9 times to the left. That is what this minus 9 is telling you. Are you getting me right? So watch as I do that. From here, I'm going to move the point 9 times. 1. Alright, so we go 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is where you expect the points to be. Alright? And so this is going to be equal to 0, 0. And then you now have points. Remember, this is where the point is. Points. We are moving on. How many zeros do we now have? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 zeros. Then 2 8s. 2, 8, and then 7 because there's no points there again. Let us conclude, please. Therefore, 28, okay, go back to the question given to us, 57.4 times 10 to the power of minus 15. If you divide it by 2 times 10 to the power of minus 6, your answer in ordinary form would be this. Now look at 0, 0. This 0, 0, you only need one of them. 0, 0 is the same as 0. Since there is no point between them, are you getting me right? So I'll just write 0 and then points. There are 7 zeros here we said. 1, 2, 3, 4, 5, 6, 7. Then 2, 8, 7. This is my answer in ordinary form. In ordinary form. Alright, B part. In standard form. We've already gotten our answer in standard form. Let me just write it out again because question B part there says we should write the answer in standard form. So in standard form, 57.4 times 10 to the power of minus 15 all over 2 times 10 to the power of minus 6 is equal to 28.7 times 10 to the power minus 9. But you know that that answer is not in its basic standard form. It's not in its basic standard form. So we need to work on it to get it in basic standard form. I've taught you that already, you know. But let me just show you. I should have just written the answer straight. Move the point once to the left and then add to this power. But let me show you the working. 0.7 times 10 to the power minus 9. This is what we got directly from the question when we solve. I'll move this point once to this place to put it in basic standard form. So our answer will now be equal to 2.87 times 10 to the power of, you moved the point once to the what? Left. So you are expected to add 1 to the power. So you have minus 9 plus 1. If you do that, should I still show you the working? Oh no, I wouldn't. Go back to the previous class if you have challenges, alright? If you move the point once to the left, you need to add 1 to the power of 10. Minus 9 plus 1 will give us minus 8 in standard form. And of course, this is my answer. We are done with this question number 3. And perhaps, for now, we are putting a stop to standard form and ordinary form. I hope you enjoyed the class. We had 3 different sections, and I hope you understood each of them. You can rewatch the video lessons from section 1 to this section 3, Section 1, just how to write numbers in standard form. Section 2, I told you addition and subtraction of numbers in standard form. And of course, this last section where we treated multiplication and division of numbers in standard form. In each of the cases, I showed you how to write the numbers in ordinary form as well too. Rewatch the video, copy out the lesson notes below each video lessons, and of course, take the quiz on them. I'll be seeing you in our next class. Get ready for that next class.